let's find the moment of inertia of a solid sphere about any diameter. To find the moment of inertia of a solid sphere, like cricket ball now, right, we are talking about. Earlier we have done kind of a tennis ball, a hollow sphere we had done. To find the moment of inertia of solid sphere of mass m and radius r, we shall be making use of the previous result what we achieved. That is, the moment of inertia of a hollow sphere about diameter is 2 by 3 mr square. So what we do is, this is a solid sphere of mass m and radius r. So this is solid sphere. So the first step is, what we do is, at a distance x, we take a sphere, hollow sphere of thickness dx. This is like considering a tennis ball, a hollow tennis ball of radius x, and it has a very small thickness dx. It is like if you put your hands like this, then this is a hollow sphere, it has a thickness dx and the radius is x. So obviously when you cut it and you open it, you get this surface. What is this area? Area of this total surface is going to be 4 pi x square, because that is the surface area of a sphere. So this is surface area and thickness is we have taken as dx. This is the ball. When you open it, this is internal radius is x. So surface area, total surface area is 4 pi x square, because that is the surface area. So this 4 pi x square, and thickness is dx. Area raised by height, that is the volume. So 4 pi x square dx is the volume of this hollow sphere of radius x and thickness dx. Probably that is the only thing what you have to understand. Rest is very, very simple. So once you find the volume of this hollow sphere, it is not the internal volume. It is where there is a material, where there is a flesh. It is 4 pi x square dx. That is the volume. So once we find the volume, we can find the mass, that is dm, mass of this. Once we find the differential element of mass of this general hollow sphere of mass dm, we can very well find its moment of inertia about any diameter using the formula 2 by 3 mr square. That is what we have just done. So 2 by 3 mr square, that is 2 by 3 dm into r is x, 2 by 3 dm into x square. We shall be using this formula and we shall integrate it from the limits 0 to r. Let's look over here. So over here we say density is mass by volume. So mass of this solid sphere is m, volume is 4 by 3 pi r cube. The dv, that is differential element of volume, is we have just done, that is 4 pi x square dx. So mass is, differential element of mass is volume into density. Volume of what? Volume of this sphere only. That is 4 pi x square into dx. This is a volume, volume into density, that gives mass of this. So about this, the very small element of moment of inertia is 2 by 3 mr square. We have just done for the hollow sphere. So pattern remains same. Over here the mass is replaced by dm and its radius is, general radius is x. So it comes out to be 2 by 3 dm into x square. So 2 by 3 dm, we put the value over here. It is what? 4 pi x square dx into rho. We put the value over here into x square. So from x is equal to 0 to r, we put the limits and it is simple integration, comes like this. So when we put it, it comes out to be 2 by 5 mr square. So moment of inertia of a solid sphere about diameter is 2 by 5 mr square.